Compound inequalities are like and statements, okay? Because that middle part is true for both of them. So it says, solve each compound inequality. Other than no solution, use interval notation to express solution sets and graph each solution set on a number line. Same directions. So look at 13. The only difference between it and what we've been doing is we have two inequality symbols. But remember, when we work an equation or an inequality, what we do to one side, we have to do to the other. But here I have technically three sides total. I have the left side, the middle, and the right side. So what I do to one, I'm going to do to all. Alright? And our goal is to get x in the middle by itself. So how am I going to solve for x on 13? Subtract the 3.
So you do it on this side.
You do it on all, yeah. Both of the outsides and the middle. So all sides. All pieces. So I get negative 8. My inequality, x. My inequality. And 7 minus 3 is 4. Did we get x by itself? Yes. So there's our solution. So we can graph this. So negative infinity, positive infinity. It's going to have a negative 8 and a 4. X is between them, so we're going to shade between. The negative 8 does not have an equal sign, so put a parenthesis. And the positive 4 has an equal sign, so put a bracket. And so we could write our solution in interval notation. Negative 8 with a parenthesis to 4 with a bracket. And then set builder notation would just be x such that, and our answer there, so negative 8 is less than x less than or equal to 4. Alright, so 14. So how are we going to solve for x? Okay, add 3. Remember what you do to one, you do to all 3. That's what I like about drawing those lines down like I do out of the inequality, or I even do it out of the equal signs a lot of times, just so I can see what's happening to one part's happening to all, so it should be equal. So we got 6, our inequality, 4x, our inequality, and what is that, 22? Then what? Divide by 4. Does my inequality change? No. Alright, now left minus fractions, but they're nice pretty decimals, so you're welcome to use them, okay? Alright, so I can see 3 halves, which is what, 1.5. 11 halves, which is 5.5. X is between them. 3 halves has an equal to, so use your square bracket. Um, 11 halves does not, so use a parenthesis. So see my interval notation. And then we can do our set builder, even though it didn't tell us to, it just gives us practice. And I can use my answer for my inequality here. Yes, good catch. So 3 halves should have the equal to in it. Alright, so y'all are working on 15 on your own here, and then we'll come back and compare our answer. Alright, so let's check it. Did we get 5 is greater than x, which is greater than negative 2? Greater than or equal to negative 2, excuse me. Yes, right? Alright, but remember we said we always run them with less than symbols. So let's just go ahead and flip it over. So it's going to be the negative 2 is less than or equal to the x, which is less than the 5. Because even if I graphed what they gave me, it would be, I'd have negative 2, I would have 5, and I can see x is between them, right? It doesn't matter that they wrote it backwards, or that when we solved it, it came out backwards. Our graph's still going to look the same. Our negative 2 is still going to have a bracket. Our 5 is still going to have the parenthesis. I'll go ahead and label my infinities here. And sometimes it just helps us when we look at it. The more proper way to write it is with your smallest number first. You'll have some, though, that will write it the other way. But I think your program likes the smallest number first, if I remember right. So we can see our interval notation and our set builder notation.